So hello students, welcome to all of you in this video lectures. In this video lectures, I am going to explain the different properties of determinant. In the last video lectures, I have explained the method how to find the determinant of a square matrix, right? Now here I am going to explain the various properties of determinant. So see, the first property is the value of determinant remains unchanged if its rows and columns are interchanged. So students, you can see one determinant is here, determinant delta. First row is A1, A2, A3. Second row is B1, B2, B3. And third row is C1, C2, C3. Now, if we interchange its rows and columns, then the first column becomes A1, A2, A3, and second column becomes B1, B2, B3, and third column becomes C1, C2, C3. Okay students, so what we have done we have interchanged its rows and columns, right? So in this case, the value of both the determinant will be same. So this is the property, the value will be unchanged if we interchange its rows and columns, right? I hope all of you understood this property. Now I'll go to the next one. The next property is, if any two rows of a determinant are interchanged, then sign of the determinant changes. So you can see one determinant here in the screen. In this screen, delta equal to A1, A2, A3, it is R1, first row. A2, B1, B2, B3, R2, second row. C1, C2, C3, R3, third row. Now here, what we are going to do, we are going to change these two row. We are going to interchange. Means we are going to write first row as B1, B2, B3, or second row A1, A2, A3. Now here, what we are changing? We are changing first and third row. Okay students, if we change first and third row, in third row, first row will go, that's first row is A1, A2, A3, so we are writing in place of third row A1, A2, A3, and in place of first row we are writing third row C1, C2, C3. So in this case we are changing one time, right? We are changing one time. In this case the value of determinant will be negative, right? We are changing first row and third row. We are interchanging first row and third row. So in this case the value of determinant will be negative. So what we have understood, that if we interchange any two rows or any two columns of a determinant, if we interchange any two rows or columns of a determinant, the sign of the determinant changes. Sign of the changes means if the value of determinant is negative, then after interchanging its rows, two rows or two columns, it becomes positive. If it is positive, then it becomes negative. So I hope students you understood this property. Next I'll explain the third one. Third one is very simple. If any two rows of a determinant are identical, means same. If any two rows or any two columns are having the same element, then in that case the value of determinant will be 0. Here you can see that first row and third row are equal. Elements are equal, 3, 2, 3, 3, 2, 3. So the value of this type of determinant we can say 0. Similarly, if any identical column is there, then also it is 0. So this is third property. I hope you understood. The fourth property is, if each element of a row of a determinant is multiplied by a constant k, then its value gets multiplied by k. So students, this is delta. We are multiplying this determinant by 4. Okay. Now if we multiply this determinant by 4, then the value of the determinant also multiplied by 4, right? If we multiply a particular row or particular column by 4, then the value of the determinant also will be multiplied by 4. So I hope you understood. The next property is, if some or all elements of a row or column of a determinant are expressed as sum of two terms, then the determinant can be expressed as sum of two determinants. You can see that in the example, one of the column or one of the row, if it is given the sum of two elements, here the first row is given sum of two elements. First element is a1, second element is lambda 1. Here a2 plus lambda 2, a3 plus lambda 3. So two elements are added in the first row, and other rows b1, b2, b3, c1, c2, c3 are the single element. Then this can be splitted into two determinant of same order using like this: a1, b1, c1, a2, b2, c2, a3, b3, c3. This is in one determinant, and using this element lambda 1, b1, c1, lambda 2, b2, c2, lambda 3, b3, c3, using this we get another determinant. Then after expansion of this, the value of this will be same as sum of the determinants of these two determinant. Okay students, both sides will be equal. So we can split this determinant like this. Similarly, if there is any particular column, if all the elements are sum or subtraction of two elements, then we can add or we can subtract two determinant. In that case, the value of determinant of both the sides becomes same. Sixth property is very simple. If in a particular row or in a particular column all the elements are 0, in that case the value of the determinant will be 0. Here the one example is given. In the first column all the elements are 0, then value of this determinant will be 0. So students, it is the last property. If to each element of any row or column of a determinant, the equimultiples of corresponding elements of other row or column are added, then value of determinant remains the same. That is, the value of determinant remains same if we apply this operation. Means if we change any particular row or particular column, okay, using the other row or column, it's like this operation, like we are going to change r1 by r1 plus k r3. K is a constant multiple, and we are going to change r1 by adding r1 with r3, constant multiple of r3. K may be 1, k may be 2, depends on the suitable constants in the question. So it depends on, it may be any integers, and we can change any particular row and particular column using such operations. In that case, the value of determinant remains same. So I hope students, all of you understood all these properties of determinant, and using these properties we can find out the value of determinant without actual expansion of the determinant. Here you can see that some questions are there. Questions are using the property of determinant, and without expanding we have to prove that the value of this determinant will be equal to 0. So students, this given determinant can be, we have written first, and we are going to change r1. How we are going to change? We are going to change r1 by r1 plus r2. When we add these two determinant, okay students, we'll get, first r1 is going to change with the help of r2. Here constant multiple is 1. So r1 plus r2. So if you add these two columns, so this is r1, this is r2. We are going to change r1, and we are adding r1 with r2. Okay, these two are adding. Okay, here r2 is fixed, r2 is constant, r2 is not going to change, r1 is going to change. So you can see that b cancelled a minus c, here c cancelled b minus a, here a cancelled c minus b will be the element of r1. Okay, and r2 is same, b minus c, c minus a minus b, and c minus a can be written as minus of a minus c, a minus b can be written as minus of b minus a, and b minus c can be written as minus of c minus b. So these elements are common. So minus is taken common outside, and the first row is a minus c, b minus a, c minus b, b minus c, c minus a minus b, and the third row is a minus c, b minus a, c minus b. You can see that first row and third row are identical. Okay, so using one of the property that when any two row or any two columns are identical or same, in that case the value of the determinant will be 0. So using that property we can say that the value of determinant will be equal to 0. So the next question is here, you can see in the screen that we have to find that b plus c, in the first row it is given b plus c, q plus r, y plus z. In the second column c plus a, r plus p, z plus x. In the third column a plus b, p plus q, x plus y, which are going to find 2 into, in the first row a, p, x, b, q, y and c, r, z. So in solution part we have taken the question, this one, and we are using one of the property, we are splitting this determinant using the third row. In third row it is given a plus b, so in the first element is b plus c, plus a, and we are writing a, q plus r, plus p and p, y plus z, plus x and x. And in the second determinant here writing b, so b plus c, plus a, and this element b here q plus r, plus p, q, and y plus z, plus x, y. Now we are using this determinant as delta 1 and this determinant as delta 2, and we are using one by one. Delta 1 is equal to b plus c, q plus r, z plus x in the first row, second row c plus a, r plus p, z plus x, in the third row a, p and x. And now we are going to start the operations. First we are going to change R2. How we are going to change R2? We are going to change R2 minus R3. So R2 minus R3. When you subtract R2, R3 from R2, so R3 is constant, R2 going to change. So A cancelled in R2, first element C, P cancelled, first element R, X cancelled, first element Z. In R3 A, P, X. So after that, again applying one more operation, R1 is going to change R1 minus R2. So after doing these operations, we are going to find the determinant as, in first row it is b, q, y, c, r, z, and the third row a, p, x. Now we are interchanging rows. We are interchanging R1 and R3 first, and then R2 and R3 first. So 2 times interchanging, so it will be minus into minus plus. So R1 is going to place R3. Again R2 is going to R3. Right. So when R1 is going to R3, then this AQ, AQY, APX is going to APX is changing APX, BQY and CRZ. Okay, so R1 is going to change with R3, right? So R1 is going to change R3. So R1 is going, first R1 is going in R3, then R3 is going to change with R2. Then ultimately this determinant will form. Okay. Now since it's minus square plus, so this will form. Now using the delta 2, using the first operation R1 is going to change R1 minus R3. So R1 tends to R1 minus R3. So here R1 minus R3, so it is B cancel C, Q cancel R, Y cancel Z. Now it is again we are going to change R2 as R2 minus R1, and we got this determinant. Again we are interchanging R1 with R2 and R2 with R3. So 2 times we are going to change, so it become plus. So when R1 is going to R2, this is going to here, and R2 is going to R3, and again this one is coming to third row. So ultimately this determinant is going to form. So you can see that determinant 2 and determinant 3 are same. So using 1, 2 and 3, okay, we can write delta equal to delta 1 plus delta 2. So delta 1, delta 2 and delta 3 are identical. So we can write 2 into, in first row A, P and X, second row B, Q and Y, and third row C, R and Z. Hence it is proved. Okay students, so it is one more questions is there, we can see in the screen. in the first row it is 1 s square minus b square. In the second element is twice ab, third element minus 2b, second row twice ab 1 minus s square plus b square, twice a. In third row twice ab minus twice a 1 minus s square minus b square, and we are going to prove 1 plus s square plus b square whole in cube. So it is the left hand side. We are doing the operation first of all r1 is going to change by r1 plus r1 plus br3, and r2 is going to change by r2 minus ar3. Okay, so when r1, if we do r1 plus br3, so we have to multiply r3 by b first and then we have to add with r1. So when you do that, 1 plus s square minus b square plus 2b square, it will be 1 plus s square plus b square. So twice ab plus minus twice ab becomes 0. Minus twice b, we are going to multiply this by b. So b minus s square b minus b cube. So you can take b common there. In bracket you can write 1 plus s square plus b square. And r2 is going to change r2 minus ar3. Okay, r2 minus ar3. So we are multiplying first. We are multiplying r3 by a. Here r3 is constant. With the help of r3, we are going to change r1 and r2. So r2 minus twice ab minus twice ab, 0. 1 minus s square plus b square. 1 it is r2, so 1 minus s square b square plus 2s square, it is 1 plus s square plus b square. Again twice a minus a plus a cube plus ab square. Here a can be taken common. In bracket 1 plus s square plus b square. Third row is fixed. There you can take common 1 plus s square plus b square. This is common from first row, and from second row 1 plus s square plus b square is common from the second row. And the determinant reduces to 1 0 minus b, 0 1 a, twice b minus twice a, 1 minus s square minus b square. Now we can expand along any suitable row or column. We can expand along r1. Okay, when we expand along r1, this is the element outside the determinant. First element into its minor, minus b into its minor. Third element is 0, so no need to write. So after expanding this 1 into this minus this into this, this is 1 minus s square minus b square plus 2s square, because it is minus minus plus, and here it is minus b, it is 0 minus twice b. So you can see that we are getting one more same factor, 1 plus s square plus b square, and after multiplying these two factors we get 1 plus s square plus b square whole in cube. So students, there is one more question, the last in this video lectures. You can see the question is s square plus 1 ab ac in the first row, in the second row ab b square plus 1 bc, in the third row ca cb c square plus 1, and we are going to prove it 1 plus s square plus b square plus c square. So this is the question. First we will take common a b c from the row r1 r2 and r3. So when you take a common from r1, we can write s square plus 1 by a, ab by a cancel b, ac by a cancel c. Take b common from r2, b cancel a, b square plus 1 by b, bc by b cancel c, ca by c cancel a, cb by c cancel b, and c square plus 1 we can write like this. So now we are applying the operation. R2 we are going to change R2 minus R1, and R3 we are going to change R3 minus R1, where R1 is fixed and we are changing R2 and R3. So when you do R2 minus R1, so this become A cancelled, will be minus 1 by A. This is B cancelled, 1 by B. Here it will be 0, and we are changing R3. So this A cancelled, minus 1 by A, B minus B 0, this is 1 by C. So we are getting this type of determinant here. Now we are applying one more operations. We are going to change column C1. We are multiplying C1 by A, we are multiplying C2 by B, and we are multiplying C3 by C. So this After that, this ABC is common. When multiply C1 by A, we get this will be A square plus 1, this will be minus 1 minus 1. This is B square 1 0, C square 0 1. Okay, now this 1 by ABC will be common, these two cancelled, and this is the determinant after we got it. Now expanding along R3, minus 1, these are the elements of R3, minus 1 into its minor. So leave this column, this is row, B square C square 1 0, then 0, this is no need to write, here it is plus 1 into its minor, leave this column, this row, minus 1 1, 1 into this row and this column, A square plus 1 B square minus 1 1. Now minus 1 into B square into 0 B square minus C square, and 1 into A square plus 1 into 1 plus B square. So after that, after simplification, we got 1 plus A square plus B square plus C square. So I hope students, all of you understood the properties of determinant and the questions we have discussed. Here I am giving some questions to all of you try it yourself, and if you have any doubts you can contact me. Thank you very much.